Hello, my name is Rob Garner. I'm a computer programming instructor, and today I'm going to overview my Blazor course. So we're going to cover why we would use Blazor, what it does, and different modes that you can use it to develop a web page. So why would we want to use Blazor? Well, Blazor is a way of developing websites that do both the front end and the server side development using C# instead of JavaScript. And it allows .NET developers to write interactive web apps just using C#. So, clearly the advantage is if you're a C# developer, this works very nicely for you. It does support JavaScript interoperability, but it doesn't require you to use it. So if you do need to do things that are custom and that require JavaScript, you do have that ability, but it's primarily intended to be used using C#. And this is for both the front end and the server side development. So before Blazor, if you're a .NET web developer, you're kind of limited for your front end to using JavaScript. You couldn't use C#. You had to use, if you wanted to use a framework for the front end, you would use Angular, React, Vue, or any other number of great JavaScript frameworks. They were very usable and still are. If you are already a React or Angular or Vue developer and you like using that, there's no reason not to use those frameworks. But Microsoft has provided a front-end framework using C# that work, so you can use C# both in the front end and the back end. And we'll see that there's actually some advantages to doing that makes it so that we can reuse things that we use, components that we create for the server-side rendering also on the client-side rendering. So there's some efficiencies that are gained by using the same language on both sides. Now, one of the things that was done before to make JavaScript a little bit more palatable for programmers that use languages like C# was TypeScript. TypeScript is still a great way of working with JavaScript. It provides a little bit more consistency across browsers and provides a more explicit typing system for the language. And it's basically just an extension over top of JavaScript. What enabled us to use C# for both the front end and the back end is WebAssembly. And what WebAssembly is it's a binary instruction format. That means it's a native code format that can be used to compile all manner of languages. So C++, Rust, Python, Go, all these languages and C# can be compiled using WASM into something that will run on the browser. And one of the nice things is it has a sandbox feature, which makes it very secure. And essentially, you can code in any language for the browser, not just JavaScript now. In fact, you will find that there's if you like, for example, using Flask for your backend development, which is a Python library for working with a server-side coding for web development, you can use Brython and actually write your front-end code for that with Python. So, whatever language it is that you like using, it's getting to the point where you can code in whatever language you want on the front end. So WASM uses a machine language for operations. It abstracts Blazor basically abstracts many of the complexities to if you were going to kind of develop WASM directly. WASM directly supports lower level languages like C and Rust, but so we create a JavaScript library. So Microsoft's created a JavaScript library that sits on top of WASM to take your C# code and make it work with WASM. That's invisible to you. Blazor does that for you. And just as a note, game engines like Unity, which is coded in C#, and Unreal, which is in C++, use WASM to create web-based games because of its performance. So you might think that, well, if we take a higher level language like a C# or C++ and run it in a browser, wouldn't it be slow? Actually, quite the opposite. It runs very well enough to run 3D games. In addition, so what we have is we started seeing this use of WebAssembly around, I think, actually .NET 3. But a lot of things have been happening through different .NET versions. Right now we are in .NET 8, and I think this has become very mature by now on implementing these changes. So .NET 8 is the framework that we're currently working in at the time I've done this presentation. And .NET now has, when it gets developed, you have an LTS version which gets issued every 2 years, and those are the even number .NET versions. So .NET 8 has come out here in 2024. It'll be supported until 2026. If you take an odd version, for example, .NET 9, which is soon to come out, it will only be supported for a year. So also, it will only be supported till 2024. So you can upgrade to the odd versions, but every 2 years, basically everything gets rehauled, and so you can expect to be on 2-year support versions if you stay in the LTS versions. So Blazor started, yes, was first released in .NET Core 3, and it was actually released in Microsoft Build 2020, and so the latest version, .NET 8, introduces the latest experience. And so Blazor is an open source web UI framework. You can actually contribute to it if you go to GitHub and find the repo. They do take pull requests. It allows building interactive web applications using HTML, CSS, and C#, not just JavaScript. And Blazor supports bindings, events, forms validation, dependency injection, and debugging. It gives you pretty much everything you need, and also authentication and authorization. It gives you everything you need to build a enterprise level web application. So there's several different modalities that you can use Blazor in. The first one is, or interactivity modes. The first one is Blazor Server. And the way Blazor Server works is when a request from the client comes into the server will actually generate your page on the server. So it actually runs everything on the server and creates a static page which it sends forward to the user's browser. From then, whenever the user clicks on things, clicks on buttons or performs actions that require the page to be updated, a Signal R connection is used to communicate that to the server, which runs the changes on your page, figures out what the difference is that needs to be on the browser page, sends that diff to the browser, and then the browser page gets updated. So all the processing in Blazor Server is done on the server. Now this is the classic server-side model. You'll see it on older versions of PHP, MVC pages, using Ruby on Rails, things like that. And so that is one of the interactivity modes. And in order to build this view, you have these Razor components, and the Razor components are very similar to React or Angular components, only in this case they'd be generated on the server. And components allow you to build little pieces of your what's on your page and reuse them. So the componenting system is very similar to React and Angular, are made to allow you to reuse code efficiently. So the advantages of a Blazor server is it's actually a very small footprint on the client, and it allows for very fast startup times. So because you're not bringing down a lot of code, you're just bringing down the result of that code. It loads very quickly. It is more SEO friendly because the server-side rendering means that the search engines will get a static page, which is easier for them to digest and process. It also allows you more compatibility with older browsers that may not be able to do all the newer things that WebAssembly and JavaScript can do. The disadvantage is it does use up more server resources. So this is building the page and responding to changes on the server. So that increases your server load. So there can be a scaling problem. And essentially the way you can think about this is if you are making for example, an enterprise application that doesn't really have a global audience, that doesn't have millions of people pinging it, this is you probably can be satisfied with server interactivity mode. If, on the other hand, you are going to be serving maybe a global population going to your page, and you do want to minimize the impact on your server, you can use the Blazor WebAssembly interactivity mode. And what that does is the server actually, and this is a classic single-page application mode where the server has compiled WebAssembly code that it forwards to the browser, and all interactivity then occurs right on the browser. Once your server gives up the application, then it doesn't do anything until your application needs maybe some data, in which case you would typically create a web API application that would just communicate data back and forth to the client-side code. So this provides offline capability. So if you momentarily lose connection with the server, the application can still run. It can also, you can actually turn this into a progressive web app, and it can be run as an application on the computer that looks just like a regular application. It really is a web app, but you can make PWAs. There's no round trips to the server on every button click, so you have a lot faster updates within the browser. The disadvantage is the download size is much larger, and so it can take long. So the user will typically see a little bit of a delay before the page starts responding when they first access it, and you don't have direct access to the database, so you have to create a web API to get access to data. So you can pick the best mode. Blazor server is recommended for existing site migrations because it's a little easier to debug. WebAssembly is ideal for offline scenarios, mobile environments, and really it comes down to how many people you're serving. If you need to scale up to a really large number of clients, WebAssembly is your preferred mode. Now, another way you can build Blazor applications is you can .NET MAUI, which is a framework Microsoft has for building mobile and PC apps, actually also supports Blazor. It normally uses XAML, but you can also use Blazor. So with Blazor, you can actually reuse your components that you're using for your web application to also make a mobile and PC app. This is great if you you're building a web application, but you're anticipating that you're going to need a Android application to work with this, and so this is a great feature as well. And once again, without Blazor, you would have to have probably a second or development team for your Android application, maybe a third development team for your iOS application, maybe a fourth if you wanted a PC, and all those teams would have to coordinate all their development in order to get features to come out at the same time. Now that we have Maui that does mobile and PC and it uses Blazor, you can do all of that together. Another mode that they're introducing with .NET 8 is server-side rendering. This is actually a very static mode of rendering. It's much more like traditional HTML and CSS, and so you can use this for a lot of your pages are pretty static. They don't have a lot of interactivity, and so you can use server-side rendering for everything that doesn't need server-side Blazor or WASM. And so this allows a lot of optimization. And what we now have, it used to be called Blazor United, but now it's just a natural feature of Blazor, is we have an auto mode now where we can mix server-side rendering, Blazor server, WebAssembly interactivity modes, and pick the best mode by each page that we create for, or each component, Blazor component that we create for our web application. And there's even a way that it will automatically switch between server-side and client-based rendering, so that when the user first accesses the page, a very quick server-side rendering gets presented. Then the Blazor server app gets rendered, and then once Blazor WebAssembly loads in the background, then the Blazor WebAssembly gets used, invisible to the user, but it allows the best of all worlds. Very quick viewing of the page initially, so the user has something to look at, moving very quickly to offloading all of that, all of the load from the server to the client. It's a little elaborate when you use all this together, but it's a lot of performance in about the most optimal way you can use it possible. So the great thing about Blazor, it's very flexible, it has a lot of potential. It's a great way of unifying your web app development, your iOS, Android, and PC app development, so that you have a minimum amount of rebuilding applications for different formats. And so it's a very exciting and very efficient way to develop applications. Thank you very much.